Okay, Aaron, continue.
Okay. So any Kotlin program, it starts from a function called main function. To understand what main is, first we need to understand what a function is. So function is any specific task. Like when we say eat is a function, right? In our real life, we say eat, and eat means consuming something, consuming a food. So when we say eat, we mean the specific task, consuming food. And like a walking is a function in our real life. That means moving forward with our feet. In the programming world, the function means the same. It means very specific task. When you did our compose task, there are some function like sign up screen. So sign up screen has a specific task to display the screen like that, right? So we had some function called surface. Surface has a task to draw the surface on our mobile screen, and lazy column has a task to hold the list of text field, and each text field has a task to show a field with a text. Like that, main is a function, and main means the initialized function of the Kotlin. So when we say main it is the starting point of our function, right? So we can't write any Kotlin function without the main function. And to define a function, first we need to write the fun keyword. Fun indicates function, and then we need to name the function. In our case, the function name will be main. It should have a bracket to indicate that it is a function. When we start a function, and this is called block. When we surround it with a pair of curly braces, we will call it block, and we will write the task the function needs to be done inside the block. So we can write a function like walk, and it would print, and we can call the function walk as much as possible to print. If we write this again, it will print it twice. We write it again, it will print it again. So uh, and then we'll move over some of the data structures, some of the common one, not very deep one, or which we'll go over later. We'll go over some data structure. So what is data structure? Data structure is some kind of as James explained it, this is some kind of cup or something we can put our data into, right? So for specific data, we have
Uh,
specific cup.
the strategy to manage and maintenance the data.
Yes, yes.
How we
So
can organize the data with efficient way.
yes, sir. And so for example, we can't hold water. Uh, we can't hold water, right? In a paper wrapper, we can hold water, right? For water, we need some kind of plastic bottle or water glass. So water needs some kind of plastic bottle, or for our daily shopping, we can use a paper box, something like that. So for like that, in Kotlin programming, for number like 1 2 3 -1 -2, we will use a data type called integer, right? Integer. It's not Kotlin specific. You can find it in Swift for iOS development. You can find it in C, C++, Rust. No, not in Rust, but in Carbon lang. in any other language, this is a common data structure. And by integer, when we say integer in programming, you can understand that it is some kind of number, right? Like you can set age, like age is equal to 20. So here age is a number like 20. It can be 20, it can be 30, it can be 40. And then we are holding the data into something called integer, which can we write like that int. So in Kotlin we can write.
Previous was for the Java format.
Yes.
Okay. No need to be semicolon also.
But there is a problem with integer. Integer can't hold.
Semicolon don't need it here, I think.
Yes, it's not.
Okay.
But integer has a problem. It can only hold floating point. It can't hold any floating point number. For example, if we want to hold right, like 90 Fahrenheit, so it can't hold Fahrenheit. Any floating point number, it will give an error in our IDE. For example, if we write it here, then it will get an error. But that is it. A floating point literal does not expect a type int or integer. So to hold floating point number like 19.0, 0.12, 0.96, we need something called float. So float is a data structure like integer, but it is different in the way that it can also hold floating point number. So it can hold something like 14.0, or we can say where is equal to 62.5, like that. So apart from these two, we have also have long and double, but I think it's not needed for us right now. They have more special cases, and there are some limitation of integer and float. When we reach that limit, we can discuss about the double and long.
For weight, you don't need to add float in it. If you put weight.
When we are using language like Java, which are old language, we need to do that. But in Kotlin, it has a feature when we say val temp is equal to 14.0, it can automatically understand that it is a floating.
Yes.
When yes, right, it is said double.
This is the intelligence of IDE.
Yes, it can automatically detect that. But we can also write like that.
Yeah.
But it's not needed, as Kotlin is a modern language and it can understand itself. Why should we write? Why should we make our code verbose?
Yes, correct.
So as we go through, we first talk about function. Function means doing some specific task, and we can define a function and call it as much as possible in anywhere in the code. And then we talked about number. The to hold number, we are using two kind of data structure. One is integer, which can hold only normal numbers like 1, 2, 3, -1, -2, and then we discussed about floating point numbers. Then we discovered float, which can hold floating point numbers like 40.0, 40.12, 0.13, like that. So as we talk, these int and float, they can only hold one number. Oh, okay. Before going there, we can also talk about string, right? So sometimes we just don't hold a number. We sometimes need to hold a text as well, text, sentence, like something like that. So to hold a text, we can use something called string. So for example, if we say like names like so this is a name and this is actually string. A string means text. And the text can be a single number, the text can be a single character, and this text can be a sentence as well. So a string means any text, like a word, a sentence, or a single character. But as we discussed, integer, float, and string, they can hold only one object, right? Only one object. For integer and float, they are number. For string, they are text. They can hold only one text, right? Under this comma. But sometimes we need to hold a list, right? For example, if I store the age of 5 people, we can do that in an integer. Like we can do that. It can only hold the age of 1 people. But to hold the age of a list of people, we should use list, right? The name indicates what's meaning. So a list is something which enables us to hold a list of objects. But there is one caveat. When we say a list can hold a object which is of same type, right? So for example, if we list a number of age, all object, if we will store in the list, should be of number type. Like if we hold ages and we say list, so there should be 10, 20, 30. We can hold something like a string in a list. It will give error. Test it here.
But in Java, we cannot put the different data type value into a same list.
Yes, in Kotlin we can do that as well.
Yes, we can do that. We can add multiple type of multiple data type value into the list.
So
this is the biggest interface.
when we in Kotlin to define a list, we need to do something list of. So after list of, you should add this arrow key, one backward arrow, one forward arrow, and in here you need to tell which kind of data structure we are holding here. So if we hold all the number, we can say string. We can say if we hold text here, we can say string. If we hold a number, we can say int. So here we are using number, like I will say 32, age 45, 56, 98. So this is a list of ages. But there is a problem with this list of, right? So as we talked about, it is a list, but sometimes when make a list of grocery, we forget something. Like let's make a list of grocery. We say something like milk. There should be string. There text, milk, bread, like that. So if we make a list like that, so sometimes we forget to let's say we forget to add meat. Now if we need to add it later, it won't be possible with this list of parameters. So when it comes there, we need to understand two concepts. One is mutable and another is immutable. So mutable means you can mutate it, right? You can change it. You can add and remove something from this list. And immutable means we can't make any changes to this list. For instance, let's say here, this is a immutable list. So we have added 2 grocery items in the list, but we forget to add meat. So when we later want to add the item meat, we can do that because it's a immutable list. That means once created, we can make any change to this list. So uh, to make a list which can be changed, or if you say mutated, we need to call something like mutable list of, like that.
It means the list
So
can be changeable.
yes, we can add something like grocery list dot add, and we can add here meat. So both of them are same, right? List of and mutable list of. They have everything same, but one difference, that is mutable list can be mutated or changed. We can add item, we can remove item, like that. Grocery list dot remove.
So here
So the
can be
meaning is
the
very
data changing
add remove.
issues. Here can be a data changing issues. So anyone
Yes,
can change the
with
data.
list of, but
Yes.
with mutable list of we can change data. We can add or remove data, like that. But in list of, we can change anything after we create the list.
Correct.
Okay. So so far we discussed about function. So function is a specific task, as we discussed, and we have talked about three types of data structures: two for numbers, one for holding text. So one is for holding normal number, which we call integer, or int in Kotlin's term, and another was floating point number, which we call float in Kotlin's term. So floating point, and we also talked about list. So list is for uh, holding a number of items, more than one. And list can be of two types. One can be mutable and one can be immutable. So when we say mutable, that means the list can be mutated. Like we can add a new object to the list, or we can remove an object from this list. And immutable means once we create a list, we can make any change to it. We can make any change. We can make any changes. So
Okay.
these are the concept, and let's talk about something called class. Right. So class is a more complex concept. So first, talk about something like object-oriented programming. So there are three kind of programming languages, like procedural, functional, and object-oriented. When we talk about procedural, that means it's processed step by step, like C and C++, right? So that means if we write 3 lines, like down here, like, so a procedural language, that means which will be processed step by step, will start from this line, and it will do the task we have uh, asked the programming language to do, and it will move to next line and it will do that, and it will move to next line and it will do that. So
It
this
is
is
made. It
procedural.
means the top to bottom approach.
Yes, it means top to bottom. Yes.
Yes.
And it's not very practical for large project, because we have to specify everything, and we have to maintain the process, which can be done in a file like 50,000 line of programming lines. We can maintain that.
Exactly.
And there is something called functional programming. Functional programming means everything can be done with functions. As we talked about what function is, so in a functional programming, everything we would do with functions, like we would say calculate age, right? And we would provide so we'll provide the date of birth. And it will calculate age for something with some algorithm, right? So this is functional programming. So everything we do with functions, and would provide something to the functions, and function would process the data and give us the output. So for example, in our regular life, if we do something, we expect some output. We don't expect output for every task, like for working, we don't expect output. But say we went to a grocery shop, we expect when he come back, he would have the grocery item with him, right? So function can be like that. Some function won't have any return type, so we don't expect any output from these kind of functions. But for some functions, we would expect some kind of output. So as I discussed, you would expect a grocery item to be returned with you. So in this kind, we would expect the age. So we have provided him the date of birth of the person, and the function will then compare the date of birth with our current date, and it will return the age. So we expect age to be output of this function. So it could be integer in this case, as it is age. So in functional programming, we do just that. We provide something as parameter, and the program returns something in that. Functional programming is not that simple. It is a very complicated. Functional programming is more complicated than object-oriented programming, and there is has been a lot of research in recent times, as functional programming has been on rise since 2018. Programming languages like Rust, programming languages like Go, and even some programming, a part of some programming language like JavaScript's arrow functions, Kotlin's arrow functions, they are growing in popularity, and there has been a lot of research and work in this field. But for now, we can just understand that, and we can say that functional programming is a language which depends entirely on functions. And then comes the object-oriented programming, right? So object-oriented programming started in 1980s. As we discussed before, there are procedural programming languages. So from like programming languages which were used in 1960s and 1970s, like Pascal and Fortran, they are procedural languages. And in 1971, there was emergence of C and C++, which was C or not C++, which was also procedural language. But starting from that time, computer started to become more and more powerful. Ma'am, are you following me?
Yes, listen.
Yes.
Ma'am, can you understand? Please, if you don't understand, please ask me. So from that time on, computer start to become more and more powerful, and from that time we don't simply write any simple program as before, as we would write in Atari terminal or some less powerful machine like that. And there has been emergence of more complex programming project like TextEdit or Beam or some project like that. Like 123, there was a document writer which was alternative to Microsoft Word. Microsoft Word did not come then. 123, just its name was 123. So for projects as complex as that, we need something more polished, right? We needed something which can be maintained more easily, and procedural languages can't do that. They become very complex if the project gets bigger. So there was a new concept in the market which they named object-oriented programming. So in functional programming, every task is a function. So we work, we eat, everything in our life is a function. In object-oriented programming, the basic concept is everything in our life is an object. Like life itself is an object. Like a book is an object. So so in that time, there was a programming language named Smalltalk, which was very popular at that time. But the problem was Smalltalk was built by some academics, and they did not consider the practical uses of it. It was a very nice language. It was very excellent if you consider its academic side, but it was not very practical. So after that, there was C++. So C++ was a modified version of C, and which was mutated to be object oriented. And after that, we have Java. So Java is a object oriented programming, and the first of its type. And Java made object oriented programming very popular. So the language we are learning here, Kotlin. Kotlin is basically Java. It's a super type version of Java. Like Java had some caveats, like as we discussed before, we need to provide the type in Java, and so writing languages like that made the code very verbose. So Kotlin was made to avoid the small issues of Java and to make it more modern. So as we are learning Kotlin, and Kotlin is itself, it has some concept of both functional programming and both object-oriented programming, and it is mainly an object-oriented programming language. We need to understand what object-oriented programming is.
Yes.
So in object-oriented programming, the basic concept is class. So if you come here, you can select class. There is class everywhere. So it's totally depends on class. So class is something like blueprint, right? So if you heard about 3D printer, or yes, 3D printer. So if you can say that 3D blueprint. So like that. So okay, let's say that this is a blueprint of a robot. This is a blueprint of this robot. So if we print this with a 3D printer, as much as we print, it will be the same object, right? Except for the color and the size. We can say the printer that print a robot with 20 feet height, and it will print that. In that case, the first one. And we can also say that print a robot with 12 feet height, and it will print that. So what a blueprint does, it holds the design, and we provide the machine a blueprint, and the machine produces a copy of an object that was built on top of the blueprint. So if we discuss here, we will understand better. So let's say we create a blueprint of a person. So here, let's say we create a person, right? So for a person, there should be something called his face, right? So we'll say face. So a person would also have a head, hand, right? Feet. So this is a person's what's a prototype or blueprint. In here, we can say a person named Harry here, and we would say his face will, his feet would be 2, his hand would be, feet would be 2, hand would be 3, right? And the Kotlin itself, based on this blueprint, will create a person named Harry, who would have 2 feet and 3 hands, right? everything else would be the same, and we can say we will create a person Maria who would have 1 feet and 4 hands. So based on this blueprint, it will create a person named Maria. So here Maria is an object. Object in the sense that in real world we say object, right? A book. So we let's give an example of book. So there is an blueprint of a book. So the book would have pages. So how many pages it would have? So for example, in by default, it would have 10 pages. And a book should have a name as well. So demo name. And a book should have an author name as well. History. Author name. Let's say Lorca, Garcia Lorca, right? Garcia Lorca, famous Spanish poet. So this is a blueprint. If we say we would create a book, so a customer came by us and said, print a book for me. So we'll call book and we'll create a copy of the book based on this blueprint and provide it to the customer. And another customer came by and said, print another book for me, and we will do that. So we'll create a book named object. So we'll create an object out of nothing based on a blueprint we call class in programming. In programming terms, it's called class, but in our real life, we call it blueprint. Right? And based on the blueprint, what we are creating is object.
Aaron bro,
So here, yes.
please make a print function in the class. That should be clear the concept.
And it
Method,
will, as the
method.
book is a blueprint of blueprint, and
Book
if
one and book
you
two.
pass the yes,
There's
yes,
other object, different objectives will be clarified by printing a print function.
correct.
Okay. So as I say, book can hold variables, right? Data structures, but a object can have functions in itself as well. So we talk, right, we can have a function named turn page, right? So turn page, we call it So as I talked about, the book can have some variable data structures, but book can have some functions as well, right? So if the customer bought the book from me, and that means the object, had the book object, and he went to his house and he would start reading it. So to read it, he need to do some tasks, as I discussed before, specific tasks. So do the specific task. He should start by turning on the page. He can't read without turning the page. So he can do that by calling the function. That means in our real life, executing the task of turning the page. So first we have created an object based on the blueprint named book one. The customer bought the book, went to his home and start doing something. So the book had two functions. He would start by turning on the page, right? So this is a function. In object-oriented programming, we call it method. So what is method? It is function. Function and method is same concept, except the function we define inside a class, they are known as method. And the function we defined outside of a class, they are called function in Kotlin. So the customer would start by turning on page, but sometime some of his friend tell his like there is an amazing story in page number 32. So he would want to directly go to this page without turning on each page like 1, 2, 3. He want to directly go to this page. For that, we have another function defined here, go to page. So go to page, you say there is no, we are getting nothing in this function. We are just calling it. But here we need a parameter that is page. That means to go to some specific page, the class needs to know which page he wants to go. So we can take this as an input, right? So as here we would say 32. Why we are telling 32? Because this is an int. As we discussed before, integer means a normal number like 1, 2, 3, 4, 5, 6, 7, 8, like that. And here by 32, we mean that we will go to the 32 long page. Okay. Sir, should we discuss about inheritance abstraction concept like that?
Yes, I think it will be better.
Okay. I think they are more complicated, but it is recording.
But today we can continue the simple overview only, as we have only 15-minute time. Okay.
Yes. Yes.
Okay. So I think we can we can prepare a list with some topics of Kotlin, as lots of topics available there. Okay, so if we cover every day 2 topics,
concept, how much we learn, compose or whatever, it would go in vain.
yes, and every day we can cover at least 2 topics from Kotlin.
Yes, sir.
Beside the Jetpack, because whatever Jetpack, if you worked on Jetpack maximum 1 or 2 months, you can easily design any UI, because
Yes.
the Jetpack compose is not much complex, but connecting with Jetpack UI, the logic is mostly important. Functional logic is mostly important. So that
Android
we have to learn
development
the function programming.
mostly the logic. UI is
Yes.
a very small part of it.
Yes, definitely.
So, ma'am, here you can say you can see that in Android development we are also using class, functions, and everything we discussed here. So let's understand it. So in any Android project, here we needed to start the Kotlin program with a main function. And in the Android project, we need to start an Android app with something called the main activity. Right. So activities are something like screens on Android. And main activity means the main screen or the first screen we would see in an Android app. And here they're using something called abstraction, which is a more complex concept we will discuss later. For now, you can understand that main activity is a type of component activity. And inside the main activity, we are calling a function on create. So as we discussed before, function will do some specific task.
I don't create an interface and then explain it, how it will overwrite. Okay. Okay.
So
the interface will contain the
say,
business logic actually. Yes.
Let's say we have a anyway. Now first start with, so we can have a blueprint for dog, which will have a function like bark. So dog can bark, right? It will bark. And we can have another function like cat, and cat can
part.
Yeah.
So these two are not same for this class two, but dog and cat have something common in them, right? So both of them can walk, right? And if we need to do that, we need to write every function they have in common in both of these classes, and uh, they can eat, right? So both of them they can eat. But when we create very complex and large projects, sometimes we can forget to create a method or create a function the class should have. For example, in this case, the dog should have something called eat. So the short dog should be able to eat. But if we forget to add this method, in this case, dog won't be able to eat and it will die, right? So
Yes.
to enforce the idea that every animal, in this case dog and cat both are animal, so every object of the same class should have something in common, and we should the programmer should implement it. The programmer must implement it. We call something called interface. So in here, dog is an animal, cat is an animal. So we'll call something, we'll create an interface named animal.
So
So
this
animal,
interface we can use to any kinds of animal, any types of
yes,
animal.
if we create cow, the interface can we can use the in animal interface as well. So
Correct.
so we as you can see in our in before we have added some specific task like task description, like how they should eat, but here we did not do that. That's because the way a cat walks, it is different from how a dog walks, right? And the way a cow walks is not same as the dog walks. So we would enforce the method to be implemented by dog, cow, and cat, but we would not define exactly how they should eat or how they should walk. So let's implement here. So first we will make sure that the dog is an animal. The dog is an animal. So in Kotlin language, that means we are saying the dog is an animal, right? Uh, in,
Yes.
in normal simple English, we use something called is, dog is animal. In Kotlin, it is the same as this column. So dog is animal. So after we write the email, you can see that it is giving error, right? So to make this error, we have to implement the member. That means the way we talk and eat, we need to implement it here.
Yes.
So we need see we can't forget now, as in an email, if we don't write function for eat and walk, it will get error. So here we can say something like eating, like,
Yes.
so like that the cat and so like that the cat and cow both are animals. So if we add animal, so if we say in Kotlin language the cow is an animal, we need to define how a cow eat and walk, right? Because a animal can eat and walk. So we would need to do that.
Yes.
And we would say print eating like a cow should eat. And we would say walking like a cow should walk. The same can be implemented in the case of cat.
Okay.
So there is another benefits of using called interface. So for instance, a person come by our house and let's say we have a pet shop, right? And some customer comes by and asks for an animal. He does not say dog, he does not say cow, he just wants an animal, right? So we can do that. So a customer wants an animal. So we are right code. Here we can provide him any animal, but here you can see goat is an animal, but if we provide him goat, it will give an error because it is asking an animal. Though goat is an animal, we did not define, we did not told Kotlin that goat is an animal. But in the case of dog, cow, and cat, we did just that. So we can provide it a cow, and it would get given error. So the customer will be happy and will return from the shop with a cow. We can also provide him a cat, right? And he would be happy with a cat. We can also provide him a dog. He'll be happy with a dog. If we also do that with goat, if we let's say if we say that goat is an animal as well, we can also do that here. Right. Now we can
Yes.
provide him.
Okay.
Okay, I think that's everything for this class.
Yes. Yes. Okay, ma'am. So you have any question regarding this?
No, it's okay.
Okay. So so we will finish today training session now, and for more reference, you can see, you can read some blog for the data structure or object-oriented programming that is related to the programming, and this is actually the practical terms, and you have to practice it.
Okay.
And the practical term, and you will be more confident on that when you will start practicing.
Ma'am, if we continue on compose right now, you will be confused about some concept and you will understand. You would have to just memorize them. But if you understand the concept very well, things will be much easier for you. So I have shared a link here. They have used very simple terms to explain object-oriented programming. You can follow that.
I'll read that. Thank you.
Okay. Okay, so ma'am, I think we can finish today training session. Okay. Okay, ma'am. So thank you so much for joining. Oh, Aaron,
Yes, sir.
join to the DSU meeting now. I need to show you something.
Okay, sir.
Okay. So ma'am, thank you so much for joining, and have a good day.
DSU will be in the same link, right?
No, no, no. It will be the different. Okay. Go to the calendar and get. Okay. Thank you, ma'am.